to another talk on reproducibility in research. And today we have a pleasure of inviting Kacper Sokol, who is a research fellow in the medical data science group in the Department of Computer Science of ETH Zurich. His main research focus is transparency, interpretability, and explainability of data-driven predictive systems based on artificial intelligence and machine learning programs, so algorithms. In the past, Kacper has worked on enhancing transparency of predictive models with feasible and actionable counterfactual explanations and robust modular surrogate explainers. He has also introduced explainability fact sheets, a taxonomy of AI and ML explainers, and prototyped dialogue-driven interactive explainability systems. And additionally, he designed and led the development of an open source fairness, accountability, and transparency Python toolkit. Kacper holds a doctorate in computer science from the University of Bristol, and before joining ETH, he was a research fellow at the ARC Center of Excellence for Automated Decision-Making in Society at RMIT University in Melbourne, Australia, and also has held numerous positions at the University of Bristol. So quite an impressive biography. And today, Kacper has kindly agreed to talk about building diverse interactive research outputs to reach and engage different audiences. So basically, he's going to discuss his experience with building bespoke publishing workflows aimed at generating multiple output formats such as documents, computational notebooks, and slideshows from a single collection of source files. He will also review publishing toolkits such as Quarto and the Jupyter system, as well as complementary technologies and their possible customization and extension. We're recording this session. We'll be sharing it on our YouTube account and also announce on the post the link on our Twitter X account. So without much ado, I would like to invite Kacper to present his talk.
I think other people have had a problem getting on.
Where are they? Sorry, I'm just trying to figure out how I could.
No, I just realised that because there wasn't a link to click on, it's taken me a while to work out how to get in. So I'm just thinking that maybe other people are taking them a while to join.
Right. We've just had someone join and then left. Probably they're coming back. But both the link and the QR code was on our account on X. And that's the only way I share information about talks usually.
Okay, well, I'm here.
Right, great. So you've made it. That's encouraging. Right. Okay, thank you. Thanks, Kacper. So if you would like to go ahead, please.
Yeah, okay. Thanks so much for the very kind introduction. Let me dive straight into it then. So I'm Kacper. Hello, everybody. And in this talk, I'll walk you through my experience with the whole publishing ecosystem and the tools that we've developed and what has happened since I've started exploring these ideas. So yeah, in brief, I'll just describe all sorts of technologies that can potentially help you to produce better research outputs that are interactive, more approachable, more reproducible, but also for you easier to author, organize, collaborate with other people, and disseminate. You've already heard a bit about me, so I'll just briefly touch on that and move on to the topic. So I have a PhD in explainable artificial intelligence, and I mostly focus on human-centered XAI. And as you can imagine, when you do work on explaining artificial intelligence, you probably need to communicate that somehow to people. And then we figured that just putting some images or pictures in the papers may not be enough, and we need more interactive and approachable ways to communicate these explanations. And this is where my work in Taylor started, which is a cross-European project where I got an opportunity to develop these tools and look into how to improve the publishing. In between, I also worked in Australia for a bit, and I researched very robust accountable AI, so all sorts of human-centered properties. Fortunately for me, I also had some experience doing research software engineering as well as research coordination collaboration. So developing these tools, we actually had an audience to test it with, and we managed to get plenty of feedback, which helped us to refine them. Now I've recently moved, well, about a year ago, to ETH, and I'm still pursuing this explainable artificial intelligence research, but now for medical applications. And I mostly work with detection management and treatment of sepsis. Right, so let's start with the other side of the publishing pipeline, so with the reviewing, because this is what got us started. So, we have all these sorts of amazing tools on the internet to do all sorts of things. But when it comes to the work that we actually do, so writing papers and reviewing papers and publishing, there's not much there, or at least there wasn't much there back in early 2020s. So we figured, okay, can we, since we're working on AI, can we actually, and on technology in general, can we try and design or enhance tools that can help us with our own work and maybe even infuse some AI to help us in one way or the other? And we started by looking at reviewing papers. So you may know that it's usually a chore when you become a reviewer, you get this huge list of papers that you need to go through and then bid on them to get the papers you want and that you're familiar with. But, well, there is an obvious improvement upon that, right? We can get better recommendations such that you don't have to browse through all the papers. You can just get them ordered in some way that is relevant to you, so that you don't have to spend too much time. And this is where we looked at recommendations for paper reviewing, but not only that. So we were thinking, okay, can we match people with text, researchers, academics with blobs of text, for example, research papers, but can we also match people with other people? And we took a very simple approach where we just got a copy of the DBLP profiles, which have a list of papers that you've published with some keywords, titles, etc. We extracted some features out of that, computed similarity, and then returned a ranked list of items that may be relevant to you, classic recommendation. We did add some extra features on top of that. So, for example, we allowed people to specify constraints. For example, you may, for somebody's publications, you may only want the ones that were published in the past 10 years or so because somebody has changed the field. So you can add extra features on top of that, which is really helpful. And of course, because I work in explainability, we also try to make the whole thing explainable such that people actually know why certain things are recommended to them. So, keyword highlighting and whatnot. And we did test it in two different scenarios. So one was matching scientific papers with reviewers, which was super nice, and people actually found some of it useful. But then when we were organizing different events, we could use the same tool to match researchers based on their interest. But, this is not only to put people together who share interests. You may as well have a different objective. So, for example, you may want to put together a group of people with a diverse set of skills. And with this sort of tool, you can also do that. Then we looked at the actual reviewing parts. So, when you get a paper, you usually get a PDF and you make your notes when reviewing it. And then you need to reformat these notes and paste them into the paper review system, which creates a lot of overhead. And we do have better ways to do that, right? So, for example, if you look at code reviews, you get these beautiful inline comments and discussions that you can have, which means that you don't need to refer the reader to page 7, line 32 in the left column. It just makes things so much easier. And we even have this in the authoring toolkits, like, for example, Overleaf or Microsoft Word. You can add comments, you have tracked changes. So seeing all of this discussion and this review, it can become easier if we have the right tools. And you can see that happening. So, for example, the open journals have host their paper review process on GitHub. They have a checklist, they have a discussion, you can refer to things, which is really nice. And then you have open review, which facilitates some sort of a discussion, but you still need to write down your comments. So there's not a good way, for example, to reference things in the paper. But if you think about it, the whole paper production system allows you to convert all sorts of sources into a shared format, and this is usually HTML or XML. So in principle, if you have a comprehensive review platform, you could possibly convert these submissions into, say, HTML, and then facilitate this inline discussion conversation. So have something that is more intuitive and requires less effort. And just as a side note, so when we were exploring this paper recommendations, we actually realized that Open Review allows you to connect your own paper matching system into the review platform. So again, there are you can find these bits and pieces of tools and APIs that could help you achieving these goals, but it's not very well explored. So this was more or less what we started looking at. We wanted to make it easier for ourselves from the reviewing perspective. But then we realized, well, authoring papers is not that much easier, and there are tools that could possibly help us to make it better. So let's have a look at what's happening at the authoring side, which is probably more interesting to you. If you look at the evolution of how research outputs or any sort of text has been published over the past centuries, it more or less stayed the same, right? We had printing press, which was slow, and it produced things printed on a piece of paper. Then printing got maybe more ubiquitous and easier, and you could produce more copies, but still it had the same restrictions. Now we have electronic formats. And even though it may be more convenient to reproduce, to annotate, to distribute, it still has pretty much the same limitations as whatever came out of printing presses. So can we do better? And, again, there were things that happened that tried to improve upon that. If you ever came across distill.pub, it was this amazing online journal that allowed you to have this interactive articles where you could explore different things and try different things out. And again, this has a strong connection to explainable AI, just because the journal appeared more or less when neural networks came to prominence. And you had these amazing visualizations and images and examples that were very difficult to communicate just in a PDF. And this filled in this gap beautifully, where you could have this interactive articles and very engaging. You could try out some of the code that was used to generate these visualizations with Jupyter notebooks. But then a few years ago, it actually got canceled. And probably that's because there was, I'm speculating here, but the overhead required to create this article was just huge. It required so much more effort to build them. You had to know the technology around it. So it wasn't really sustainable in the long term. Then again, if you look at presentations, we sort of have the same story as with books and different forms of text. Even though it becomes easier to create, to distribute, the limitations more or less stay the same. So this is more or less from the perspective of what sort of research outputs we have. It used to be fairly straightforward. You just produce a paper, then maybe a presentation for a conference and a poster. But the list of requirements keeps on growing. So now a lot of conferences or journals require you to publish the code and your data and possibly computational notebooks so that people can play with it and try and reproduce it. You may need to record videos discussing your work, press releases, blog posts, and a whole bunch of other formats. And all of this requires you to basically duplicate what you already have, adapt it a bit, maybe generate some new content, reorganize your content, and put it in a different format. But in the end, once you start looking into how these sort of things are created, you can look instead of looking from the output perspective, you can look from the input perspective. So what is required to create this different formats and these different outputs? Well, in the end, you have some text, you have some figures that you may have created manually, or they may be code generated. You have code bases, maybe some code snippets and examples. Sometimes you may want to represent a piece of code as a pseudo algorithm, but in essence, it's the same, just different representation. Then you may have some computational notebooks, animations and videos, and maybe some other format, some other building blocks. And then you put all that together, you adapt it based on your needs, and then you put it in a particular source format, and then you generate the output. And again, we have a bunch of different source formats. You may be working with LaTeX documents, Beamer slides, with the Microsoft Suite. You may do some notes in Markdown or do it straight in HTML. You may share your code in a code repository like Bitbucket or GitHub, or you may just put it as a zip archive on Dropbox. There's no one way of doing it. But can we make it easier? Can we make it a bit more organized? So, we can, but we need to realize what needs to be addressed. So as it stands, we require multiple output formats, so documents, slides, computational notebooks, which usually means that you copy that and you adapt it. So then you may have multiple versions that are completely out of sync, and you may copy the same document when you revise it, and then just maintaining it gets out of hand. Some pieces of source materials may evolve. So for example, you may start with a workshop paper to expand it to a conference paper, to expand it even more to a journal paper. And once you apply some edits, you don't really know what's happening anymore. You can't quite keep track of that. And in the end, whatever you had in mind originally, and you end up usually with a PDF, unfortunately. So you have a PDF paper, you have a PDF slide deck, and you may even print out your computational notebook to a PDF if that's required. So can we do better? Well, we probably can. And there are a bunch of tools available that can help you with that, but every tool takes care of a different aspect of the process. So it's not that easy to put it all together and get some reasonable workflow out of it. And in the end, you ideally would like to cover the whole publication life cycle. So how you compose your materials, how you review them, and how you publish them. And yeah, you probably want to avoid always compiling everything to a PDF. So, because I'm a computer scientist and I had some time on my hands, I'd say, well, let's make it better. And yeah, as this cartoon shows, it did quickly get out of hand. So I did prototype an authoring toolkit that implemented some of these features, but then after about a month or so of development, I actually got lost in all of the features that I implemented. So I didn't quite know how to write the documents to get the output that I wanted because it got so complicated. But then other tools came along that kind of took care of the source format issues. And this is where we started prototyping with something that actually gave us useful results in the end. So the idea was that we want a single input repository. We have all of our text, code, figures in one place. And then we want to be able to have different output formats out of it, such that we can reuse a lot of artifacts. So for example, if we have a bunch of text that goes into multiple places, then we can have it in one place. Maybe we want different variants of that text. So for example, for a text document, you may have a long description of something, but for the slides, you may compress it into one sentence. But there is a link between the two. So we were trying to figure out, is it possible to have this independent source materials and then reuse them to generate different types of outputs. And this was our original idea, with the ultimate goal of actually having a composition tool that would even separate the individual input formats. So originally what we had was just a document where we already had text and maybe some code and maybe a figure, and then it got compiled into different formats in different ways. But ideally, you'd actually want to separate all of these different input artifacts and then have a tool that composes them back together. But this was a bit too complicated for the prototype that we wanted. And actually what prompted all of this was a talk that I gave for the Alan Turing Institute back in 2020, I think, or 2021. And the talk was a technical talk. It was about explainability for images. But after the talk, the most voted question was, what technology are you using for the slides? And that was because originally my presentation was supposed to be a demonstration of different explainability tools, but it got moved online, and then I had to figure out a different way to convey the message that is suitable for the online format. And I started digging around. I found this amazing thing which allowed you to do slides with interactive widgets, and I'll demonstrate it to you in a moment. But it actually showed us that these technologies may be out there, but people are not familiar with them, and people may not know how to use them. So we probably should have a look at them and try to demonstrate to people what is possible and how it can help them in communicating their research outputs. In terms of technologies that I was using and that I discovered was Reveal.JS, which is an online slides generation toolkit, Jupyter notebooks with all sorts of widgets, RISE, which allows for interactive slides, Jupyter Book, which allows you to compose an online document out of Markdown sources, and then our thing, which we call the only write thrice, which is basically a pipeline built on top of that. Since then, actually, quite a lot has happened in that space, and when I had to do some extra online learning materials, I actually came across Quarto, which solves a lot of the challenges that we initially discovered when we began to work with the publishing workflow. So let's start with Reveal.JS. You may not have heard the name itself, but it's actually very likely that at some point you've used Reveal.JS. So Reveal.JS is a web framework for building slides. You can either write them directly in HTML and have the slides, or you can write them in Markdown with some special annotations and then generate your slides. You can also have different formats, and there are many converters available. So for example, you can have your content in a Jupyter notebook and then have Reveal.JS slides out of it. Since we've started playing with it, it actually became quite popular and it got integrated into a lot of tools. So for example, if you do your notes in Obsidian, there is a feature there to generate slides out of your Markdown notes. And this basically uses Reveal.js. So let me just show you one example of how that works. So if you want to do it in Markdown, you can basically have a Markdown file, and you can see these extra annotations here, where it tells you that it's a slideshow and it separates another slide. And for example, you should not display this slide. So again, if you read it as a Markdown file, or you can also convert it to a Jupyter notebook, you will see all the content. But once you convert it into the slide format, some of this extra information that is not necessary for the slideshow will basically disappear during the conversion. So just let me show you the actual raw file. So yeah, in the end, it's just Markdown with extra annotations. And what you get out of it is an online interactive slideshow with a lot of cool features. And it makes it so much easier for you to actually distribute your slides. And again, you can have it as a Markdown file. So there's a lot of portability there. Right, let's move on to the next thing that we were playing with. So Jupyter Notebooks, a lot of you probably know Jupyter Notebooks. They're pretty much standard when you try to do some prototyping. And also they got integrated into a lot of products that we use. So for example, GitHub offers native rendering of Jupyter Notebooks. You can also host them somewhere else and then use NV Viewer. And again, you will get it nicely rendered on the web. But all of these are static. So in order to execute Jupyter Notebooks, you actually require compute. And then there are, again, online tools that allow you to execute the code within Jupyter Notebooks without installing any sorts of packages on your personal machine. And this, for example, are Google Colab and MyBinder. So again, let me just briefly show you some notebooks. So here it's a Jupyter notebook that is displayed through GitHub. And like I said, you can go through that, see the code, see some explanations, see the figures, but you can't execute anything. If you host it somewhere else, you can also open it from NV Viewer, which is pretty much the same view. But then you may want to play around with it. You may want to change some parameters here and see how this affects the output of the code. And again, this ties back to my work on explainability, where we wanted people to explore different aspects of explainers and try and better understand how, for example, tweaking different input features for AI models affect their predictions. So yeah, you can launch these notebooks straight from GitHub, say, and then you can actually execute the code and play with them. And again, I think Binder failed for me, but you more or less get the same execution environment online to play with your notebooks. So that's great. Now we get to the actual interesting bit, which generated the question, what technology do I use for my slides? So RISE is an extension for the Jupyter ecosystem, which allows you to convert a Jupyter notebook into a Reveal slideshow. So I showed you the Markdown source files and the source file, and then the Reveal.js presentation that I got out of it. You don't necessarily need to write the source in a Markdown with these annotations. You can also write it in a Jupyter format. And you may not know that, but every cell in a Jupyter notebook can have metadata. And again, in this metadata, you can specify whether a given cell is a slide or how how basically it should be treated when you export it to a presentation. The big advantage of the RISE is that it actually works on top of a Jupyter instance. So when you export slides otherwise to Reveal.JS, obviously there's no compute behind that, so you can only have static slides. But because RISE builds on top of a Jupyter instance, you can actually still have access to the execution environment. And again, let me just give you a brief example of how it works. So here you can see a Markdown file, but it's a Markdown file that can be easily converted into a Jupyter notebook, hence why you get all of these annotations. So whenever you see +++, it basically means this is the end of a Jupyter cell. So again, you can easily convert it to a Jupyter notebook. And if you have the right extension installed, once you open that Markdown file, it basically becomes a Jupyter notebook. And any edits you do here get saved into the Markdown file. So again, it depends what sort of format works better for the content that you're authoring. So for example, if you have a text-heavy content, then probably editing it in a Markdown file makes more sense than editing it in a Jupyter notebook. Whereas if you rely more on code, then it's probably easier for you to work with a Jupyter notebook because you can execute it and debug it. So where the magic comes? Well, you may know that in Jupyter, you can have interactive widgets that allow you to basically change certain parameters, and then the function behind gets executed and the output of your function gets updated. And what is interesting with RISE is even though it's the same Reveal.js set of slides, actually now the cells that have code remain interactive. So if I were to generate a HTML straight out of this format, then it would get compiled into a static Reveal.js presentation, and this figure would be static, of course, with the default parameters that I set in my Jupyter notebook. But now, because I have an execution environment behind it, I can change these parameters and the graph changes in my slides, which is quite impressive and really good if you try to explain certain concepts and show people how different inputs or different parameters may affect a certain process. Then we have Jupyter Book, which basically allows you to have a bunch of content in Markdown or in Jupyter Notebooks or in any other notebook format that is compatible, and then generate a nice looking online article or online book. You can have Python code embedded in that, which means that you can either show the Python code itself as listing, or you can execute this code in order to embed a certain object within your document. So for example, instead of doing the figure by hand and then embedding a JPEG figure in your content, you can have a piece of code that is responsible for generating this figure, and the figure gets generated during the book compilation process. You also get a bunch of extra scientific typesetting features like BibTeX, bibliography management, LaTeX equations, cross-referencing, etc. The nice thing about being able to use Python directly for certain elements of your book is that, for example, you don't really need to typeset a table as long as your code can produce, say, a NumPy array or a pandas data frame. It gets really nicely displayed in the content. Same with figures. And again, this means, for example, if you want a report based, if say you generate a report rather than a book or an article, then you just replace the input data, generate your report, and you get new features, new figures, new tables, no extra effort required. which is super helpful. So for example, just to give you an idea when it may come in handy is when I was doing my content, at some point I decided to change the design of figures in the book. And instead of going through every single figure one by one, I basically injected a piece of code that configured matplotlib for me, and then all the figures got regenerated as I wanted. So it say if you use it right, it can save you a lot of trouble. And again, let me show you just briefly an example of what to expect. So here I have a GitHub repository with a bunch of source files, and most of these are markdown files that have a certain part of a paper. And then this gets generated into a really nice web page where here you have sections of the paper, but also, for example, I can embed links to the open review, a bunch of PDFs. I can link to the review that happened on open review for that paper. I can embed a video for that paper. The presentation that I gave for that paper during a conference was recorded on Slides Live. So again, I can have a Slides Live presentation here embedded as well, my poster and whatnot. It's static. So for example, I do have slides here as well, but you wouldn't be able to execute any of the interactive widgets, but you can still launch the slides themselves. So again, there's a bunch of content there and different formats all kept together so that you don't need to worry about your inputs diverging, or if you, for example, fix a typo, it gets propagated to every single format that I generate out of these sources. But of course, no tool is perfect. So we have these individual things, but can we do better? And the idea of our idea was basically to try and pull off this together so that you can have this nice content management system. This is what you saw a moment ago. So this one set of source for Jupyter Notebook, and then we have a pipeline on top of that that generates slides, embeds different elements, generates bibliography, etc., etc. So in our case, we had Markdown and Jupyter Notebooks that got generated into the Jupyter book, the document, Reveal.JS, so the presentation, but also Jupyter Notebook. So some elements in that paper are interactive, and you can either get a static view of that in the HTML presentation and in the Jupyter book, but you can also have an interactive version once you launch one of the notebooks, either through My Binder or Google Colab. And then you can also, on top of that, have this interactive presentation from there on. Yeah, so just to summarize, the idea was to have more from single source to have all different formats, and we had Jupyter Notebooks, Reveal.JS, Jupyter Book. We wanted to manage the content in different ways. So for example, the same piece of information could be a long textual paragraph for the book, could be a short sentence for the slides or the notebook. Or for example, if you generate slides for different audiences, you may mark the slides, individual slides within your source material as of different difficulty levels. So for example, for some people, you may only want the easy set of slides. If you're talking to the lay people, if you're talking to students, you may have a different set of slides. And through annotating the content like that, you can generate these different formats and still have a single collection of source documents. And then, of course, because we keep all of that in a Git repository, we get full history of the edits. We can do discussions on individual documents, parts of it, sentences. We can propose changes, and we can keep track of everything. But yeah, as I said, because you only write thrice relies on pre-existing tools, it has certain limitations. So at some point we were doing an online version of a textbook, and the textbook was about logical programming and Prolog. And unfortunately, you can't get Prolog to work within Jupyter Book. So then we started digging a bit deeper, and Jupyter Book is based on Sphinx, which is the Python documentation engine. And because it is based on Sphinx, you can actually write your own Sphinx extensions and then integrate them with Jupyter Book, which allows you to have your custom elements that are easily embedded within these different formats. So again, let me just quickly show you what we did. So for example, one thing is a way to put nice animated terminal windows within Jupyter Book. And all you need to embed such an element within your Jupyter Book is a simple terminal block that specifies what sort of lines you want, what sort of delay you want, and just with that, you can have a nice terminal window embedded in your Jupyter Book. Then with respect to the Prolog book that we were doing, we had to extend with exercise and solution windows. So again, we have this simple exercise and solution blocks that have the corresponding tags and then links between them, which again simplifies the whole thing. We also added Prolog to Jupyter Book, and this is actually quite neat because instead of specifying that it's Python or something, you just say that it's Switch, so an online execution environment of Prolog, and then you get this interactive code boxes where you can execute Prolog directly in the web browser. We did the same for cplint, which is similar to Prolog. Again, you have these neat code windows. And we also did it for Problog, just because it wasn't too much of an extra effort. And with all of that, we were able to port the entire book into Jupyter Book. And as you can see, it has all sorts of different types of outputs that we were able to achieve with our extensions, like exercises, code blocks, code listings. So if there isn't something that you need from any of these tools, there's usually a way to implement it. Coming back to reviewing, as I said, once you have everything in a repository, you can have these very rich discussions and issues and change requests that are permanently attached to a document. So for example, if you imagine submitting a paper for review and the changes that are required are too big for it to be accepted, then you can have a continuous review and you can track the changes continuously, which probably saves a lot of time. In terms of publishing, as I said, we have this workflow that builds Jupyter Book, Jupyter Notebooks, slides, etc. from single source. And in our case, we implemented that as a GitHub action that executes everything and generates these sources, uploads them, and publishes them. But this also means that you can tag certain versions of your document and then easily archive them. For example, Zenodo or even Mean the DOI have a nice way to reference different versions, but also have some better bibliometric tracking. So for example, you could use Google Analytics with any of these online outputs and actually see which page people are spending the most time on and what's most useful. And then when it comes to presenting the outputs, you actually, the nice thing is that in the end, you actually don't even need your own computer to present this. You just need a URL. and you can display or use any of these three formats. They don't require any software on your machine. You can just browse them anywhere in the browser. And I suppose it makes everything way more convenient, and you are only limited by whatever modern web technologies offer. I think I have one more thing, one more demo of the whole thing. So yeah, this is just to recap that we can have all of that within an online document generated from a single source, and all of that is available on GitHub, and you can have a look at it, customize it to your liking. But since we've done all of that, which was probably late 2020, early 2021, a lot of things have changed. And I think the biggest change for the better is Quarto. Quarto is an open source scientific and technical publishing system. And I think it very well embodies the mission that we set out to achieve with our custom scripts and custom pipelines that required a lot of tweaking. So with Quarto, you can actually write your content very similar to Jupyter Book and to our framework in Jupyter Notebooks or in Markdown files. It supports a bunch of scientific features like LaTeX equations, citations, cross-referencing figures, both ones that you generate from code and just normal figures, JPEGs or whatever you want to embed, code listings. You can also have different variants of the same source code. So for example, say you are writing a book and you want people to have code snippets in both Python and R. You can have that as well. And then it allows you to generate this different artifacts like articles, presentations, again, presentations with Reveal, dashboards, website, blog post, books. So it very much embodies what we want to do. And, you know, it's an open source tool that actually people are working on. So unlike our rudimentary workflow, it probably offers you a bit more features and is a bit more stable. And then you can generate two different formats as well. And so I used to rely on my bespoke workflow quite a bit, but then when I came across Quarto and I was about to create some new content for a course I was teaching, I decided to give it a go. And it actually fulfills a lot of at least my requirements, and in general, I suppose, a lot of requirements that you may come across when trying to produce reproducible research outputs. So just to give you one example of how I used it, I was preparing a course and I mostly needed slides, and it was a course on explainable AI. So I also had some machine learning models and some explainability algorithms. So I wanted to show people how different explanations change depending on how you configure explainers and what sort of models you use. And most of it is written in, again, some flavor of Markdown. So you can see that there's some text there, but also a bunch of Python cells. And out of that, I have a bunch of these Markdown files, each one on a different topic. And out of that, you are able to create a website that basically describes the course, but also it generates slides. So if you click on any of these links, you get a Reveal.JS slideshow. And again, most of these figures are generated with Python. So I didn't have to do them manually, then put them in the presentation. If something has changed, regenerate everything from scratch. Actually, whatever you change within the source repository is reflected when you regenerate the slide. So for example, say, if I'm explaining one particular machine learning model, and then I want to change that model to a different one, I can just change one line of code and regenerate these slides, and then suddenly I get slides for a different model. Unfortunately, this does not support interactivity yet, as I showed you with RISE, but I bet that there is a way to get around it. But yet there are these tools and they're getting more popular, and it's just so much more convenient than having a Jupyter notebook with code that generates the figures for me and then me having to manually paste them into a PowerPoint presentation, then me distributing this PowerPoint presentation, which would probably be huge on the internet, everybody having to download it. It makes teaching, in this case, easier, especially that the students can get these source materials. And if they want to experiment with a certain explainer, here they can just change some of that and see how that affects. So the learning experience is also enhanced. How do I see this going forward? Well, there's already a lot of features implemented in Jupyter Book, in Quarto, but in the end, these are open source tools. And if you need a feature, you probably can implement it. One of the questions around this sort of a publishing workflow is, where do you host it? How do you maintain it? So you could possibly use commercial tools such as GitHub or Bitbucket, but in the end, these are commercial. So this may not be sustainable in the long term. And also in terms of executable content, a lot of it requires compute. So you usually need a server running somewhere that evaluates your code. There is some progress. So with WebAssembly, I believe you can have Python that is executed directly in your web browser without any extra compute, but this is still somewhat limited. But I see a lot of it. Well, a lot of the things that we wanted to implement actually are becoming more and more popular and easier to use. So I'm quite hopeful in terms of us as researchers having the tools available for making our work a bit easier and for disseminating our research a bit better. Thanks so much. I think we have 5 minutes or so for questions, so I'm happy to take them if there are any.
Yeah, thank you very much, Kacper. It's fascinating, especially for a neophyte like me. So I saw there are at least a couple of links in your slides. It would be great if you could share some useful links. I could attach them to the recording for people.
Yeah, of course. I have all of the links in the speaker notes for the presentation. I can just export them, and then you can get a list of resources.
Oh wow, that would be great. And yeah, it was great that you talk about the way forward, and because we anticipated some of the questions. But I'm also wondering that as someone who would like to get started with this, so what would you recommend for setting up a workflow that can generate these multiple wonderful outputs from a single source? So where to start with?
The good thing is, for example, with the one that we set up just as a demo, is that you can just clone the repository, put your own content in there, and the GitHub action will generate everything for you. So even if you're not technically minded in that sense, for you to set it up yourself, you can just clone the repository and put your content in there, and the rest is pretty much taken care of. And because, again, all of the output formats live on the web, you don't even need to download them or distribute them. GitHub, for example, allows you to have your own web pages per repository. So then you just need to know the URL, which is derived from the repository name and your GitHub username, and you can share that with people straight away. They can help you. You can collaborate on different elements of your source materials. So even if you don't really know how to set it up, it's as easy sometimes as just cloning the demo repository and putting your content in.
Right. So is it like as simple as just signing up on a particular website and then getting started?
Usually, yes. Sometimes, so for example, if you require some bespoke Python packages for your code to be executed, then you may need to add a line or two saying, I want to install this and that package. But again, if all that there are also, for example, I think my binder uses it, packages that try and figure out what sort of packages you are using such that they get installed automatically. So a lot of these things can get streamlined such that you can actually focus on writing your content as opposed to setting everything up.
Yeah, okay. And any particular challenges related to using these wonderful tools?
Well, so I must admit that, for example, when working with Jupyter Book and writing extensions in Sphinx, I think it's a bit funny because Sphinx is a documentation toolkit for Python, but Sphinx itself isn't that well documented. So I run into a lot of issues trying to figure out how Sphinx works and how I can implement my own features with Sphinx API, because the documentation is quite cryptic. So it took me quite a bit of time to figure out how Sphinx works and how basically to write these extensions such that they achieve the goals that we had in mind. But there's a learning curve there. And for Quarto, again, the extensions are in a different format. And I think Quarto is written in Lua, maybe? I don't know. But it's a different program language and it's a different environment. So being able to write these extensions is challenging in the end. And you need to then weigh pros and cons, right? Do I want to invest a lot of time in developing this extension because I will use it repeatedly over the next 5 years or so? Or is it just a one-off thing and I'm better off just, hacking my way through it or doing it manually?
Yeah, these are all relevant, good points. Well, yeah, thanks very much. I know that you need to leave at sharp at 3, so I'm not going to take much of your time. Wonderful. I'm just going to share all of this. And if you could just, please send the links, that would be excellent.
I will send you a list of links to attach to the presentation.
Excellent. I'm finishing the recording here.